How would you do that? So first of all, you have to buy a lot of servers. Why servers? Because obviously you'll be hosting a website on something, right? So you have to buy a lot of servers. And every website has a peak time. So keeping that peak time in mind, you have to buy some more servers. Thirdly, you have to monitor and maintain these servers. Since these are your own servers, you have to continuously monitor them so that your application doesn't experience any downtime. And once you encounter a problem, you have to maintain them, right? So these are the things that you have to do. Now these things led to problems. Now what are those problems? Let's address them. So first of all, this setup was very expensive since you're buying a lot of servers, and guys, servers are not cheap, they're very expensive, right? So this setup was very expensive. Secondly, since you have to troubleshoot problems, they usually conflict with your business goals, because your aim should be making your application better, right? But if you're also thinking about whether your application is or is not facing any downtime, or is your server hardware configuration is up to date or not, you are not investing that much time on your application as you may need to, right? So it used to conflict with your business goals. Thirdly, since your traffic is varying, your servers will be idle most of the time. So what this basically means is, since you bought a minimum number of servers keeping the peak time in mind, now, what about the time when the peak time is gone, right? Let's take an example. Say suppose your peak time is between 4 p.m. when your website is experiencing the most traffic, right? So if your website is experiencing the most traffic between 4 p.m. to 6 p.m. and you place in, say, 5 servers to handle that kind of traffic, what about the time which is there after 6 p.m.? After 6 p.m. when the traffic goes down, you say you need only 2 servers which can handle that traffic now. What about those extra 3 servers, right? They become a liability on your investment, because since you have invested a lot on those servers, but you cannot utilize them now because you don't have the need for them after 6 p.m., right? So it becomes a bad investment, hence it was a problem. So these were all the problems that people faced before cloud computing. Now we had to fix these. So let's see how did we fix them. So we came up with cloud computing. So now in cloud computing, instead of buying servers, you actually rent them, right? So instead of burning a lot of your investment on buying servers, you can actually invest it on some other things, maybe a better idea or maybe hiring more people, right? So first of all, the foremost thing that you are renting servers cuts down your cost into a fraction. Secondly, scalability was a problem. So now with cloud computing, you can scale up or scale down according to your needs. So you don't have to foresee what kind of future your application will have, or what kind of future or what kind of traffic will be coming in the future. As and when the traffic comes in, you can scale up or scale down as and when required, right? So scalability was again an issue which has been solved with cloud computing. Thirdly, now you don't have to manage your servers. All of that tension will be done by your cloud providers. You just have to focus on your application. So your cloud provider will manage all the updation which is required, the security patches to ensure that your application is not facing any downtime. The only thing that you have to do is choose the right cloud provider. Because if you choose a new player which is out there in the market, just for saving a few dollars maybe, your application may not become that much successful, because new cloud providers are not equipped to handle the kind of problems that you might face, right? So you have to be very careful when you're choosing your cloud provider. So guys, this is how we address the problems that we faced before cloud computing. Now, any questions until now, any questions that you have that should be answered before we move ahead? All right, I have a question from Michael. So Michael is asking me on which parameter we should decide to choose which cloud provider. All right, Michael, good question. Michael, you have to consider in a lot of things. Say suppose let's talk about AWS. So AWS came in the cloud computing market in 2006, right? And if you compare it with other cloud providers, say suppose Azure. So Azure came in 2010, right? So compared to Azure, AWS has a more mature model of infrastructure. And if I was you, I would choose AWS on Azure, because AWS has seen a lot since it has started. It has become better in terms of handling problems which come up when you're hosting someone else's application. Apart from that, you also take into account what kind of server capacity does a cloud provider have, and what kind of companies are associated with the specific cloud provider. So suppose if you talk about AWS, so AWS is hosting application for Netflix, which is a very successful video application. So if Netflix is not facing any downtime, you can be assured that your application is in safe hands as well, right? So these are all the parameters that you take in mind when you're choosing a cloud provider. So Michael, does that answer your question? All right, Michael says yes. Any other question, guys? Anything related to cloud computing, how cloud computing became important to us, or why cloud computing came into the picture? All right, since it's a yes from all of you, let's move ahead. So now, since now we've understood what was the need that led to cloud computing, let's understand what cloud computing exactly is. So what is cloud computing? So cloud computing is the use of remote servers to store, manage, and process data. So you do three things. You store, you manage, and you process data. So when I say store, you're storing your files, say, on a file system on the cloud. So when I say manage, you're managing your data using databases there on the cloud. You process your data. So you're using computing power on the cloud to process your data. Suppose you have a huge chunk of file that has to be processed, right? And you don't have that kind of machine in your own infrastructure. So you can always rent a server from AWS with the right kind of configuration, and you can use that machine to process the data or process the file that you want to process, right? And once you're done with that, you can always terminate a machine and you will pay AWS according to the number of hours that you have used it for. And that is the power of cloud computing. You don't have to buy that computer exclusively to process that file. You can rent that server from AWS, use it, and pay them according to your usage. Right? So guys, this is what cloud computing is all about. Any questions, any kind of doubts that you have regarding cloud computing now? So Michael is asking me, so is it pay for use? Yes, Michael, you pay according to your usage. Yes, you're bang on. The pricing model is pay per use. Good to know that you know about cloud computing, Michael. Any more questions, any more suggestions, guys? Any more thing to add which I just told you guys? All right, Michael says no. Sandeep says all good. All right, I'm getting confirmations. All right, guys, let's move ahead then. So we talked about cloud computing and how it is a successful model, right? So it is bound to have competition in the market. So if you want to become a cloud provider, you will have a lot of competition in the market because this concept is huge. It's very advantageous. It's very successful, right? So a lot of people are trying their hands at cloud computing. But it's a fact, there are a lot of cloud players out there. But why are we discussing about AWS? Why are you learning about AWS? Why do you want to become a solution architect for AWS, right? So let's put a light onto that and discuss why AWS. So these are the three parameters that we'll be discussing. So first up, we have AWS Global Cloud Computing Market Share. So AWS has a global cloud computing market share of 31% as compared to its competitors, which have a cloud computing market share of 69%. Now you would say 31% is nothing compared to 69%, right? But then the thing here to understand is that AWS alone has a share of 31% in the global cloud computing market share, and no one, not even Azure, which is the closest competitor to AWS, has a number even near to 31%. So this number is huge. AWS is leading by a very huge margin. Let's talk about the second parameter, which is the server capacity. So let's consider that all of its competitors combined, when I say it, I mean AWS. So all of AWS's competitors combined, say, have a server capacity of X. AWS alone has a server capacity of 6x, which is 6 times the server capacity of all of its competitors combined, right? So if you have an application which is very successful and you foresee that there's going to be more traffic in the future, your safest bet would be on AWS because they have that kind of infrastructure for your application to grow. And that is why AWS has such a large user base. Let's come on to the third point, which is flexible pricing. Now, any enterprise, big or small, wants flexibility in its pricing, right? They want to cut down their cost. They want value out of their money, right? And that is what flexible pricing is all about. So AWS charges you for the hour, right? So when you use AWS servers, and suppose you use them for 3 hours, you don't have to pay for the whole day or for the whole month. You just pay for 3 hours. And with this kind of flexibility in their pricing, it has attracted a lot of customers, right? So this is the reason that AWS is so successful today in the market, and that is why you guys are learning about AWS today. But that does not mean that the other cloud providers are not performing well. If you look at Azure, which was just launched in 2010, it is the closest competitor to AWS. But if you see the current scenario, if you take in mind the current scene, AWS is still leading, AWS has more job opportunities, and AWS is more successful than any other cloud provider. Maybe 3 years or 4 years down the line, other cloud providers will start coming at par with AWS, or maybe they'll surpass AWS. Like I said, if you see the current scene, AWS is the thing, and that is the reason we are learning about AWS today. That is the reason you are here. That is the reason I'm teaching you guys about AWS today. So guys, are we clear why are we learning about AWS, or why you guys are attending AWS's training rather than some other cloud provider? All right, Michael says yes. Others, Neil, Sandeep, okay, they say all good. So everybody is giving me a yes. So let's go ahead. So since now we have understood the why of AWS, let's understand the what. So what is AWS? So AWS is a secure cloud services platform. So it's a platform on which Amazon offers its cloud services, and it offers its cloud services in compute, database, content delivery, and other domains. So AWS is a secure cloud services platform. So it's a platform on which Amazon offers its cloud services. In what it offers its cloud services? It offers cloud services in compute, it offers cloud services in database, and a host of other domains. So having said that, let's discuss the different domains in which AWS offers its services. But before that, guys, any questions that you have regarding what AWS is about? All right, Neil says no, Sandeep says no, Michael says no. All right, guys, let's move ahead then. So let us now discuss the different domains in AWS. So these are all the different domains in which AWS offers its services. So first up, we have compute. So in compute, there's a service called EC2. So EC2 is Elastic Compute Cloud. So it's just like a raw server. So you can configure the server to be anything. You can use it to host a website. You can use it as a work area environment. It's a clean slate. It's just like a new PC that you buy. So install a fresh operating system on your PC, and then you can configure it to be anything. You can install any software you want, and then it can serve you as you require, right? And that is what EC2 does as well. Right, so this is the compute domain. Next up, we have the migration domain. So migration domain is when you want to transfer your data to the AWS infrastructure, or you want to transfer your data back from AWS infrastructure. Next up, we have the migration service. So this migration service is used to transfer data to and from the AWS infrastructure. So if you have petabyte scale of data in your data warehouse or in your data center, and you want to send it to AWS infrastructure, you would be using services in migration. Now there's a service called Snowball in migration, which is used to physically transfer your data to AWS infrastructure, right? So basically what AWS does is, it sends you a physical device, which is just like a hard drive, to your premises, and you transfer your data onto it, and then AWS ships it back to the infrastructure. Now this is Snowball. So it offers similar services in the migration services. Now you would ask me, why are we sending our data physically to AWS infrastructure? Why not through the internet? So like I said, if you have petabyte scale of storage in your data center and you have to send it to AWS infrastructure, it is better to send it physically rather than sending it on the internet. You can imagine it just like giving some data to your employees. Would you give it on a hard drive, on an external hard drive if the data is large, or would you send them an email regarding that, right? So just like that, you can imagine this scene. Next up, we have the domain, we have security and identity compliance. So in security and identity compliance, you have services like IAM, which is used to authenticate users and define user rights to them. So say suppose you're running a company and you have a root AWS account. Now you want other employees to work on your AWS account as well, but you want them to have restricted access. Say suppose you want user one to maybe just launch instances, and user 2 can only edit instances but not launch instances. Maybe user 3 can only review the instances and not launch or edit these instances, right? So all of these granular permissions can be given to your users using IAM, and that is what security and identity compliance domain is all about. Next up, we have the storage domain. So storage domain would include services like S3, which is simple storage service. So it's a file system. It's an object-based file system in which you can store your files and access them as and when required. Right now, people usually get confused between the storage domain and the database domain because basically they're storing data, right? So why two different domains? So storage, like I said, would include services like S3. So it's a file system. Now, what is the difference between a file system and a database? So a database cannot include your executable files. So say suppose you have an image file. So that image file would not be stored in a database. It's better to store that image file in a file system and hence access that image file using a path which can be stored in the database. Right? So this is basically the difference between a file system and a database. So like I said, it includes services like S3. So S3 is an object-based file system in which you have buckets and objects, which we'll be discussing further in our slides. Moving on, we have the networking and the content delivery domain. So it includes services like Route 53. So Route 53 is a domain name system which basically redirects your traffic from the URL that you purchase from, say, a domain selling website like GoDaddy, and redirects it to your instances or your servers which are hosting your web application. Why do we do this? Because you cannot remember the IP addresses, right? You need something solid, you need something simple. And that is what domain system is all about. It translates the simple into the IP address and redirects your traffic to that IP address, right? So this is about Route 53. Next up, we have the messaging domain. So messaging domain is all about services like, say, suppose simple email service. So it is used to send emails in bulk to your customer base, right? So if you have an application where you have to notify your customers about a new update, so rather than sending emails to each and every customer, you can, with a click of a button, you can send it using SES, and you can also handle the replies that customers give, right? So all of that can be managed using SES, which is a simple email service, which comes under the messaging domain. Next up, we have the database domain. So database domain would include services like RDS, which is a relational database service. So a relational database service basically manages some databases for you. It's not a database in itself, but it's a managing service which manages databases for you. So it can manage databases like MySQL. It can manage databases like PostgreSQL. And when I say manage, they can automatically update the DB engines, or they can automatically commit to your changes. All of that is managed using a management service in Amazon, which is RDS, which comes under the database domain. Let's move on to our last domain, which are management tools. So management tools are basically tools using which you can manage your AWS resources. So in this domain, you have services like CloudWatch, which is an all-in-one cloud monitoring tool. So you can use this tool and monitor all the AWS resources that you have running in your AWS infrastructure. Right? So guys, these are the different domains in AWS. These are the different areas in which AWS offers its services. Any doubt regarding any of the domains that we just discussed? All right, I have a question from Neil. So Neil is asking me, what is content delivery? So good question, Neil. I mentioned content delivery and not explain what content delivery is actually about. So content delivery is basically a caching service. So what it basically does is, if there's a user which is far from a server which is he's trying to access, so data on that server is cached to a location near the user so that the latency becomes low, so that the response time is faster, right? And that is what content delivery is all about. I will be covering content delivery in detail in the coming slides, so just have a little patience. I'll explain everything in detail. Any more questions, guys? Anything related to the domains that we just discussed? All right, Neil says all clear. Michael says no. Sandeep says no. All right, guys, let's move ahead then. So since now we've discussed in what areas AWS offers its services, let's discuss the AWS services, right? So the first domain in AWS services is AWS compute domain. So let's discuss the services under compute. So the first service is EC2. So EC2 is the most important service in the whole of the compute domain. So why do I say it's the most important service? Because EC2 is the base, and the other services which are Lambda and Elastic Beanstalk are just advanced version of EC2. How? Let's discuss that. So EC2 is, like I said before, is just like a raw server. Now you can configure this raw server to be anything, right? You can configure it to be a web server, like I said, or a worker tier environment or something else. Now, and this web server can be resized according to your needs. The instances or the servers that you've launched, they can be replicated, as in you can launch multiple servers of the same configuration, or you can also increase the configuration as well, right? So this is the kind of resizability that you get with EC2, and this is what EC2 is all about. So guys, are we clear with what EC2 is? So the first service in the computing domain is EC2. So EC2, like I said, is just like a raw server. You can configure EC2 service to be anything. So it can be configured to become a web server. It can be configured to become a worker tier environment. The softwares that you require can be installed, and the server can be configured in any way required, right? And that is the kind of independence you get that when you're using EC2. But what is the difference? You can resize the server as and when required. It can be resized according to the number of servers that you're using, as in if you're using, say, suppose a particular configuration and you want to deploy the same configuration again, and you want to host or you want to serve your application through these number of servers, you can do that. Or otherwise, you can also increase your configuration on your particular instance. Now, the way to understand this is, say, suppose you're using the i3 configuration right now. You're using the i3 processor on AWS, and you want to go on to i5. You can do that. You can do that kind of resizability as well. So this is the kind of flexibility you get when you're using EC2. So guys, are we clear with what EC2 is all about now? All right, people are giving me a yes. All right, guys, let's move ahead. So let's move on to our second service now, which is AWS Lambda. So AWS Lambda, like I said, is an advanced version of EC2. So it's based on EC2, but the difference between EC2 and Lambda is Lambda cannot be used to host your application. Lambda can be used only to execute your background tasks. Now, what are your background tasks? Say suppose you have an application, right? And your application is all about images. So when you upload an image, that image is compressed and it is stored on a file system, right? So your image will first be uploaded to the file system, right? So when the image is uploaded, that is performed by our application. Now the tasks which have to be done in the background, like the compression, or maybe you have some more tasks like applying filters and everything, these tasks are background tasks, and these tasks can be executed using AWS Lambda. Now, how does AWS Lambda functions is like this. AWS responds to events. So there are triggers that you set up in AWS Lambda, and in response to these triggers, AWS executes the code, right? So in this case, in our example that we took, that we are uploading a file, right, or uploading an image. So the moment that image gets uploaded to, say, suppose S3, which is the file system for AWS, a trigger is generated, and that trigger is being listened by AWS Lambda. So when that event is listened by AWS Lambda, it responds to that event using the code that you provide. It executes that code and then sits again and waits for another event to happen, right? Now that code would include your code for compression, applying filters, etc. And that is how AWS Lambda functions. So guys, are we clear with how AWS Lambda functions and what AWS Lambda is all about? And what is the difference between EC2 and AWS Lambda? Right? People are saying yes. All right, guys, let's move to our next service now. So our next service is Elastic Beanstalk. Elastic Beanstalk is again an advanced version of EC2. But with this, the difference between Lambda and EC2 and Elastic Beanstalk is that, first of all, Elastic Beanstalk is used to host an application. So if you compare it with AWS Lambda, this is the difference. Elastic Beanstalk is used to host an application. Lambda is not used to host an application. So this is the difference between Lambda and Elastic Beanstalk. Now let's talk about EC2 and Elastic Beanstalk. So Elastic Beanstalk is an automated form of your EC2. How? With Elastic Beanstalk, you don't have to configure in all the details, you don't have to set up your environment. Say suppose you have a PHP website that you want to host on EC2. Now for your PHP website to be hosted, you first have to create a PHP environment in your EC2, right? But with Elastic Beanstalk, you don't have to do that. You just have to select what kind of environment you want, and AWS will install all the configuration files required and will give you the environment on which you just have to upload your code, and your application or your website will be deployed. Right? So this is how simple Elastic Beanstalk is. You create your environment and then you upload your code. That is it. Nothing else is required. So as you can see in the diagram, say suppose you have a PHP code. So you create a PHP environment first, launch it. Once that environment is created, you upload the PHP code and your application is deployed. As simple as that. So guys, are we clear what Elastic Beanstalk is all about? All right, people are saying yes. Neil has a question. So Neil is asking me, when would you use EC2 and when would you use Elastic Beanstalk? Very good question, Neil. So Elastic Beanstalk has a limited number of environments, right? So if you have an environment or an application which has to be hosted, and the environment is listed in Elastic Beanstalk, you should go ahead with Elastic Beanstalk. But say suppose your environment is not there in Elastic Beanstalk. Maybe Elastic Beanstalk is not ready to host the environment yet. Maybe your use case is not about hosting an application. In that case, you would be using EC2, right? You'd not be using Elastic Beanstalk. So these are the differences, Neil. Any doubts in what I just explained, or do you need any more further explanation on this? All right, Neil. Any other question, guys, regarding the differences between the EC2, Lambda, and Elastic Beanstalk? Any confusion that you guys have? So Michael is asking me, does this mean that configuration is easy in EC2? No, Michael, I mean it the other way around. With Elastic Beanstalk, the configuration is easy because you just have to select, like I said, right? If you want to host a PHP website on your server using Elastic Beanstalk, you have to select the PHP environment. But if you were to do that in EC2, which was a raw server, you can do the same thing in EC2 as well, but you first have to install the PHP software in EC2. And by PHP software, I mean you have to install the PHP environment in EC2 so that your machine is now ready to understand PHP, right? And you also, since you have to host a website, you have to configure your firewall to be secure. You have to configure your firewall, allow incoming traffic onto your server, right? So all this configuration has to be done in EC2. But with Elastic Beanstalk, you don't have to do all these configurations. Everything is done automatically. You just choose whether you want a worker tier environment or you want to create a server for website hosting. You select website hosting, you choose your environment, and you upload your code. You don't have to deal with the firewalls. Everything is managed automatically. So does that answer your question, Michael? All right, Michael says, is any other question, guys? Any doubts that you have? All right, people are giving me a go. Okay, guys, so let's go ahead. So let's discuss what is Elastic Load Balancer. So Elastic Load Balancer basically is used to distribute your workload among a number of instances, right? Now, the traffic which will be coming on these instances has to be distributed equally among these 5 or 6 instances, right? And this is what Elastic Load Balancer does. Now, why is this important? Say suppose you have 4 or 5 servers running and all your traffic is directed to your first instance, right? So it doesn't make sense because all your other 4 servers are idle. You have the capacity with you, but you have not installed a protocol using which the traffic can be distributed to these 5 instances. And that protocol is Elastic Load Balancer. So Elastic Load Balancer distributes the workload equally among the instances so that the work is done efficiently and also the work is consistent. As in, if I am using, say suppose a website which is being hosted on AWS, I should experience the same kind of response time as you are experiencing using the same website, right? Say suppose my request is going to the 5th server, which is less busy, and your request is going to, say, the first server, which is more busy. In that case, your response time and my response time would become different. That is why we use Elastic Load Balancer. So if I am using your website and you are using the same website, you and me will experience the same kind of response time because it's being distributed equally among the instances and the instances are busy on the same level. So this is what Elastic Load Balancer is all about. Any questions, guys, regarding Elastic Load Balancer? Any kind of doubt that you have regarding the service? All right. Let's move on to our next service, which is auto scaling. So auto scaling is a service which is used to scale up and down automatically without your manual intervention. Now, how do you do that? You set up metrics. Now, say suppose you have a website running and that website is running on 5 servers. okay? And you configure a metric that whenever combined CPU usage goes beyond 70%, launch a new server, right? So whenever your CPU usage will go beyond 70%, it will launch a new server, and then focus guys, and then the traffic will be distributed among the 6 instances, right? So I said distributed, so this work is done by Elastic Load Balancer, and that is why auto scaling and Elastic Load Balancer go hand in hand. They have to be used together. So if you're using auto scaling, you have to use load balancer as well, right? And like I said, you can scale up using that metric, and you can also set a metric for scaling down. Say suppose your combined CPU usage goes below 50% or goes below 10%. So you can configure your auto scaling to decommission a server in that case, and hence you can scale down from the number of instances that you're running. And again, your workload will now be distributed to, if you had 5 servers before, it will now be distributed to 4 servers, which again incorporates Elastic Load Balancer. So like I said, auto scaling and Elastic Load Balancer have to be used together. So guys, any questions regarding any of the services that we just discussed? All right, Neil says all clear. Sebastian says all clear. Michael says all clear. All right, guys, let's move ahead. Before moving ahead, let's make it interesting. We have studied a lot of theory. Let me deploy a new EC2 instance for you guys. So let's go ahead and deploy a new EC2 instance. So I'll go on to my AWS console and sign in. So this is how your AWS dashboard looks like. These are all your services, right? So since we have to deploy a new EC2 server, we'll be clicking on EC2, which you can find under the compute domain. So let's click on EC2. Now this is the EC2 dashboard. Over here you can monitor your EC2 instances. As you can see, I have 2 running instances as of now, and I have 4 snapshots, 4 volumes, and 51 key pairs. Right, so you can monitor your EC2 services from over here. Since we are launching a new instance, we'll click on Launch Instance. Alright, now you have to choose an AMI. So AMI is nothing but an operating system that you would use to, that you would want on your EC2 server, right? For now, let's launch a Windows server. So let's click on Windows. Now you will be asked for the kind of instance that you have to select. Alright, you don't have to worry about the instances as of now. You can select the t2.micro. And don't worry, because we'll be discussing everything in detail as we move ahead in our journey, and when we come down to the EC2 module, we'll be learning all about these different instances. So for now, just click on t2.micro and click on next. Now it's asking me how many instances do I want. Okay, since it's a demo option, since it's a demo, I'll launch only 1 instance. And then it's asking me the networking settings and everything. Okay guys, don't worry, everything will be discussed in detail in the EC2 module. For now, let's just focus on deploying this instance and click on next. Ignore if you don't understand, I will explain everything to you guys. Alright guys, now we come on to add storage. So with Windows, by default, you have to launch with a minimum of 30 GB. You can also expand it over here as per your requirement. So I'm okay with 30 GB. Let's click on next. So now we have to add tags. So what do you want your instance to be named, right? So you can give your name over here. So the key is name, the value could be a Windows server, right? Let's click on configuring security group. Alright, a security group is basically like a firewall on your instance. It is used to control the inbound and the outbound traffic which comes on your server. So how to do that? We'll do that in the modules that'll be coming in the coming weeks. For now, just understand what security group is all about. So it is used to control the inbound and outbound traffic. If you don't understand that as well, it is okay. We'll just click on review and launch. So we'll review all the settings which we have just done. Everything looks fine to me. Let's click on launch. Alright, this is a very important step. Now the way you get authenticated to your instance is with a private key and a public key configuration. So it's called a key pair. So basically you can create a new key pair as in a new public key and a private key, or you can use an existing one. So the public key is kept with AWS and the private key you can download, and whenever you want to connect to your instance, you'll be using the private key You'll be uploading a private key to the console that you have for launching your instance, and that private key will be matched against the public key, and you will be given a password, and using that password you can connect to your instance, right? So whenever you're creating a new key pair, you have to keep your private file handy and you have to keep it safe, because once you lose it, you cannot connect to your data is gone, right? So you have to be very careful with your private keys. So for now, let me create a new key pair for you guys. So let's click on create a new key pair and give it a name, say AWS demo. Right? So let's download our private file. Alright, it says that AWS demo already exists. Okay, let me give it AWS demo 1 and click on download key pair. Alright, my private file has now been downloaded. Cool. Let's now launch my instance. So my instance is now launching. Meanwhile, let's go back to the EC2 dashboard and check if you can see if our instance is being listed there. So we'll go to EC2. So as you can see, we had 2 running instances before, but now we have 3. So since we have launched a new EC2 server, we can see 3 running instances, right? So let's click on it and it will list you all the services which are running. So we named our instance to be Windows Server, so here it is. The instance type is t2.micro. You can also look at the key pair that we have launched it in. So it's called AWS Demo 1. You can see the timestamp here and you can see the security group here. So once you click on your instance or once you select your instance, you can see all the details attached to your instance. Say suppose the public IP. So this is the IP that you'll be using to connect to your instance. So your instance type, your instance ID, the VPC, subnet, everything can be monitored over here. So the way we'll be connecting with this Windows instance is using a remote desktop connection. So once you open your remote desktop connection, it will ask you for an IP address, right? So that IP address has to be copied from here. So this is your IP address that you'll be copying. So once you copy this IP address, it will ask you for the username and the password. So by default, Windows uses a username called administrator, and for the password, you have to upload your PEM file, which is over here on your launch console, and it will decrypt a password for you by matching the private key with the public key, which is there with AWS, and then using that password, you can connect to your Windows instance. Sounds simple, right? So let's do it. It's still initializing. Let's wait for it to initialize and then we'll start with our demo. Meanwhile, guys, do you have any questions as of now? The services, the EC2 service which I just launched, do you have any doubt in whatever steps I just did? Alright, people are saying no. Alright, guys, let's just wait for instance to be launched then. So our Windows server is now running. We can see that it says green over here and it says running. Alright guys, let's launch or connect to our instance now. So you'll be clicking on actions and you'll be clicking on connect, right? Then you'll be prompted on for the screen and then you'll click on get password. Once you do that, you'll be asked for a key pair path. Let's choose our key pair now. So we'll go to desktop and we'll choose the key pair which is AWS demo 1. We'll click on open and we'll click on decrypt password. So I can see the password here now and I can see the username, right? Let's now connect to our instance. So let's copy the password to somewhere. So this is our IP address. So like I said, we will copy this IP address and we will launch the remote desktop connection. So it's asking me the IP address. I will paste the IP address over here and click on connect. So it's asking me for my credentials. So since my username is administrator, and then I will copy the password that I decrypted. Let's click on OK. So as you can see, it's now connecting to my server, which I have launched on the AWS infrastructure. And this is it. So this is your desktop, guys. This is the server that you launched on AWS infrastructure. So just like a fresh operating system, you can click on start. You can see the way you would see it on your machine. Now you can install any software over here and you can configure this server to be anything. Pretty cool, right? So guys, this is what EC2 is all about. This is how you connect to your EC2 server once you launch it. Alright guys, let's come back to our slide. So we just learned how to launch an EC2 server on AWS infrastructure. We learned how to connect to a Windows instance on AWS. Alright guys, any kind of doubts that you had in the demo session or any doubts in the services which we just saw? Alright, Michael says no, Neil says no, Sandeep says all okay. Alright guys, let's move on to our second domain, which is AWS storage domain. Alright, so let's discuss services in the storage domain. So first up, we have these S3, which is simple storage service. So S3 is a file system. So it's an object-oriented file system, which basically means that all your files that you upload on S3 are treated as objects, right? And these objects have to be stored in a bucket. Now, what do you mean by a bucket is you can consider the bucket to be a folder. So the root folder has to be a bucket, right? You cannot just